there, this is me Kanita Rahman and you are on my channel Content Factory. Today I'm here with a new topic, computer graphics. In this lecture, we'll study Introduction to Computer Graphics, some basic concepts related to it, its types and application. But before going to our topic, subscribe to my channel and click the bell icon so you will get my videos on time. Coming back to our topic, the word computer graphics is made up of two words. One is computer and the other one is graphics. Now first look at what is computer. A machine instructed to carry out operations. What that means? A computer is a machine, or you can say a device, that performs operations that we instruct to it. And the other word graphics. The word graphics comes from a Greek word that means belonging to drawing. And its definition is real images or designs on some surface to inform, illustrate or entertain. Here the surface may be any wall, it can be a stone, canvas or even the screen. The real images, for example, you can say lines, pictures, charts, graphs or maps or any design is drawn on that surface. And what's the purpose of that drawing? That may be used for information, illustration or entertainment. That means graphics. Combining the two words, we get computer graphics, and it's a subfield of computer science. It may be defined as the discipline of generating images with the aid of computers. That means in computer graphics, we generate images, for example, lines, pictures, animations, graphs, maps, etc. with the help of computer. In computer, if we specifically say with the help of programs and softwares. For example, I'm sure you all have heard about Adobe Photoshop or Adobe Illustrator. These are programs and with the help of which we can generate images. This all discipline is called computer graphics. Now, there are some processes under computer graphics, or you can say that some tasks we perform under computer graphics. First one is representation. Description of something in a particular way. Or you can say that how we represent something, any object we are drawing, how we describe it or how we represent it is called representation. The other one is manipulation. Any modification made to text, images, sound, video or other data is called manipulation. We can explain it as changing anything that is previously existing. Changes made to that object is manipulation. The third thing is storage, the way of keeping information in memory for use of computer or user. The graphics stored in memory, save for the later use that may be used by computer, that may be used by the user, is the storage. These three processes are very important under computer graphics. Next come to the very important concept in computer graphics, and that's pixel. Pixel is also called picture element. And what's the definition of pixel? Smallest discrete component of an image or picture on CRT screen. Now what is CRT screen? We're gonna learn about it in our next lecture. For now, just imagine CRT screen as a screen on which an image is displayed. Suppose this is a screen and an image is displayed on this screen. Then the smallest discrete component. Discrete component means we can distinguish it clearly. So the smallest discrete component of that image is called pixel. In other words, the smallest controllable element of the picture represented on a screen is the pixel. How that pixel works? Look here, working. The graphic monitors display images by dividing the display screen into millions of pixels. Suppose this is a screen and an image is displayed on it. This screen is divided into millions and trillions of pixels, or you can say that this screen is made up of millions of pixels arranged in rows and columns. Many pixels are arranged with each other. They are so close to each other that they look connected and form an image. The pixels depend upon the resolution of screen. The more the resolution of the screen, the more the pixels are there. Or you can say the more the pixels on a screen, the more the resolution of that screen. Now here look, each pixel typically consists of 8 bits. For black and white image, if there is a black and white image, that means that each pixel on that image is of 1 byte, that means 8 bits. But if the image is colored image in RGB form, RGB means red, green and blue form, then there should be 1 byte for each color, that makes 3 bytes, and 3 byte means 24 bits. A pixel in a colored image is made up of 3 colors, red, green and blue, and that forms a pixel. Next, look at this images. This is a screen. This total is a screen. Can you see the rows and columns here? This is the row and this one is the column. Look at this box. This box represents a pixel. All the boxes here represent a pixel, and adding them all forms a screen. Now, look at this image. This simile is made up of pixels. Pixels are colored by black on a white background and a simile is formed. To understand this term here, resolution, first let's discuss what is resolution. Definition: the number of pixels in an image. The number of pixels in an image is called resolution of that image. Or you can say the number of pixels in 1 inch or the number of dots per inch in a canvas is called resolution. How the resolution is identified? Resolution is identified by the width and height of the image as well as the total number of pixels in the image. We should know what's the width and height of that image and how many pixels are there in that whole image or whole canvas. If we know these 3 things, we can know the resolution of that image. The resolution determines sharpness and clarity of that image. What that means? The more the resolution of the image, the more sharper the image, the more clear that image. Now look at this image. Here the canvas size is 20 by 20 pixel. What that means? That means in row there are 20 pixels and in column there are 20 pixels. And per inch, DPI means dots per inch. Per inch of this canvas there are 9 dots. Now you can see this image is very much blur. That means this is not clear because its resolution is not that high. It's just 9 dpi, 9 dots per inch. Now look at this image. Its resolution is 18 dpi, 18 dots per inch, and size of canvas is 40 cross 40 pixels. That means 40 pixels on row side and 40 pixels on column side. And this image is more clearer than this image because its resolution is high. Now coming to the third image, its resolution is 90 dpi, that means 90 dots per inch, and canvas size is 200 cross 200 pixels. That means the rows and columns have 200 pixels on each side. Look, this image is very much clearer than both of these just because its resolution is high. Now let us discuss about types of computer graphics. There are 2 types of computer graphics, raster graphics and vector graphics. Raster graphics are composed of pixels. We have just learned about pixels. And vector graphics is composed of paths and lines. That means that in raster graphics, the image is made up of pixels. The pixels form an image. But in vector graphics, we plot two dots on the screen and a line is formed between them. In vector graphics, the shapes and graphics is made up of mathematical formulas and equations. Coming to next, when raster graphics are enlarged, their size is increased, they become distorted. Look at here. This is a raster graphic. As you can see, as we enlarge the image here, it becomes distorted. We can see the pixels here. It's not a smooth surface, but it's an irregular surface because it's a raster graphics. Now come to vector graphics. It can be scaled very large without any loss. Its smooth surface is not lost when we make it large because it's not made up of pixels. It is made up of paths and lines. There are two of the file formats that support raster graphics. There are many file formats that support raster graphics, but two of them are here, JPG and GIF. Have you seen that when you take selfie and you enlarge it, it becomes blur? It's because the selfies are taken in raster graphics. They are stored in raster graphics. That's why when you enlarge it, it becomes distorted. But here, vector graphics, some file formats are .eps, Adobe Illustrator. Its abbreviation is .ai. And we design logos in it. Why we design logos in vector graphics and not in raster graphics? Logos have to be scaled very large at some times, so it's necessary that they don't get distorted. That's why logos are made in vector graphics. In next lectures, we'll work in Adobe Illustrator and you will get to know how we use vector graphics and how we use raster graphics. Now coming to next topic, we can divide computer graphics as interactive computer graphics and non-interactive computer graphics. What that means, interactive, the word interactive comes from the word interact. Interact means communication. Communication between user and computer. When you are able to communicate with the computer, you are in the mode of interactive computer graphics. You can control the graphic images in interactive computer graphics. For example, when you are playing video games, you can control the computer by your moves by clicking the buttons. That's an interactive computer graphics. When pilots are trained by the computer-based models, they can make changes according to them to those models. That's why they're also an interactive computer graphics. But what about non-interactive computer graphics? In non-interactive computer graphics, you cannot interact with the computer. That means you cannot control the computer. You don't have control over the graphic images. So you don't have a communication there is no communication between user and the computer. It runs as it is programmed. For example, screenshot or you are watching a movie, that's a non-interactive computer graphics. Now, what about applications of computer graphics? There are so many applications of the computer graphics, some of which I have listed here. First one is entertainment. In entertainment, movies, animated pictures, computer games, all such come under entertainment, and these are the applications of computer graphics. Next come presentation graphics. In presentation graphics, we produce illustrations. For example, PowerPoint. We use PowerPoint and other tools to present our illustrations, and the purpose of it is summarization of the content we have. Next is education and training. In education and training, computer graphics is used to produce computer-generated models. These models help learn the ship captains and pilots how to operate their devices or how to operate their equipment. Next is visualization. Visualization means converting data to real form. What that really means? That means if we have data, for example, of the population of cities of Pakistan, then it's very difficult to learn them in the form of statements. So we make them as points or in the real form. It becomes more efficient. This process is called visualization, converting the data to real form in the form of charts or in the form of bars. Usually scientific, engineering, medical and business data are converted from data form to real form that brings efficiency in it. And this is the application of computer graphics. Next is image processing. To to mo- sorry to modify or interpret existing image. If there is an image and you want to change it, you want to add something new in it, this is called image processing, and its applications are in medical field. Next one is computer art. There are graphic tablets where we can make electronic paintings. That's one of the applications of computer graphics. Next one here is cartography. That means map making. We can make maps in computer graphics, for example, geographical maps, weather maps, population maps, and so on. Next one is simulation and animation. What does animation mean? Creating an illusion. What does illusion means? That means an object is not present in physical form in front of you, but you can observe it in 3D form as if the object is right in front of you. That's animation. And what is simulation? The production of computer model for study purpose. Many models are built, computer models are built for study purpose, for studying the physical phenomena that are not possible in real world. And that's the application of computer graphics. Next is CAD. CAD means computer aided designs. This is used for precise designs. Engineers and architects use them to make the structure of their devices or the houses schemes, etc. Next comes desktop publishing. What does desktop publishing means? Production of printed material using any software. For example, you use any software to make anything out of graphics and then you print that out. That means desktop publishing. Next comes user interface. Many of you have heard about GUI, graphical user interface. If you are a computer science student, you may have noticed icons, menus, and multiple windows on your interface. These are all the applications of computer graphics, and these have brought efficiency in using computers. Next is graphical charts. You can make many charts out of computer graphics, pie charts, bar charts, and so on. These are some of the applications I have listed above. There are many more applications of computer graphics. Enough for this lecture. In next video, I'll come up with input-output devices used in computer graphics. If you like the video, do subscribe, like, share, and comment in case of any query. Till then, take care. Goodbye.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.